Somewhere in the depths of space, a moon erupts in spectacular fashion. Geysers of ice shooting hundreds of miles into the void, harboring secrets that could rewrite everything we know about life itself. Right now, beneath Martian soil, microscopic fossils may lie frozen in time, whispering stories of a world that once thrived. And across the galaxy, worlds unlike anything in our imagination orbit distant suns, each one a potential cradle for the unthinkable. We stand at the edge of the greatest mystery humanity has ever faced. The question isn't if we're alone anymore. It's where we should look first, and what we'll find when we do. For generations, we gazed at the stars and wondered, are we the universe's only witness to its own magnificence? Today, that ancient question has transformed from philosophy into science. Our telescopes pierce deeper into space than ever before. Our rovers crawl across alien landscapes, and with each discovery, the universe reveals itself to be far stranger and far more promising than we ever dared imagine. From the frozen moons in our celestial backyard to the scorching super-Earths orbiting distant stars, from the mysteries beneath our feet to the apocalyptic phenomena that reshape galaxies, the cosmos is calling. And finally, we're ready to answer. The search begins closer than you think, hidden beneath a shell of ice thicker than mountains. One of Saturn's smallest moons conceals an ocean that dwarfs all of Earth's seas combined. Enceladus, a world of eternal winter and impossible beauty. When our spacecraft first witnessed its southern hemisphere erupting in crystalline plumes, scientists realized they were watching something extraordinary. These aren't mere geysers. They're windows into an alien sea, one that never sees sunlight, never feels the warmth of a star. The water itself tells a story, laced with organic molecules and minerals, warmed by tidal forces that squeeze and flex the moon's interior like a cosmic heartbeat. Down there, in the absolute black, hydrothermal vents could be pumping heat and nutrients into the depths, the same conditions that sparked life on Earth 4 billion years ago. If life can emerge once in our solar system, why not twice? But Enceladus isn't alone. Europa, Jupiter's ice-bound jewel, conceals even more water beneath its fractured crust. And Titan, with its methane lakes and organic haze, presents a completely different possibility, a world where life would be unlike anything we've encountered. These aren't distant dreams. These are missions in development, spacecraft being built, futures unfolding within our lifetimes. Meanwhile, on Mars, the evidence grows stronger. Our rovers have become detectives, piecing together clues from a crime scene billions of years old. The Perseverance rover has discovered something remarkable in the ancient rocks of Jezero Crater. Organic molecules, structures that look suspiciously like fossilized microbial mats, chemical signatures that, on Earth, would be considered smoking guns. Mars wasn't always the frozen desert we see today. 3.5 billion years ago, rivers carved through its surface, lakes filled its craters. The atmosphere was thick enough to trap heat and shield the surface from radiation. For nearly 1 billion years, Mars might have been a paradise for primitive life. But then, something changed. Mars lost its magnetic field, and the solar wind stripped away its atmosphere. The water froze, then evaporated into space, or locked itself beneath the surface as ice. And if life existed there, it either died out completely or retreated into the deep, waiting, dormant, for someone to dig it up. The samples we're collecting now are coming home. In the next decade, those carefully sealed tubes will journey back to Earth for analysis. What we learn could change everything, because if life arose independently on 2 worlds in the same solar system, then the universe isn't just populated, With life, it's teeming with it. Beyond our solar system, planets exist in configurations so exotic they shatter our assumptions. Super-Earths, worlds larger than ours but smaller than Neptune, with gravities that would crush human bones, and atmospheres thick enough to blur the line between air and ocean. And dozens of them sit in the habitable zones of their stars, where temperatures allow liquid water to persist. Consider K2-18b, a super-Earth orbiting a red dwarf 24 light-years away. Recent observations detected water vapor in its atmosphere, along with hints of molecules that, on Earth, are produced only by living organisms. This world is 8 times more massive than Earth, with an atmosphere potentially hundreds of miles thick. If life exists there, it could be floating in permanent cloud decks, never touching solid ground, evolving in an environment we can barely conceptualize. Then there's Proxima Centauri b, our nearest exoplanetary neighbor, at just over 4 light-years away, locked in tidal synchrony with its star, one face in permanent day, the other in eternal night. Could life exist in the twilight zone between extremes? We don't know yet, but this is a world we could actually reach with advanced technology. Thousands of exoplanets now populate our catalogs. We've found worlds orbiting binary stars, planets where it rains molten glass sideways, gas giants so hot they vaporize rock. And among these extremes, we're learning that habitable is far more flexible than we ever imagined. While we search the cosmos, Earth itself continues its ancient dance, a dance that's gradually slowing down. Our planet's rotation isn't constant. Every century, the day grows longer by about 1.8 milliseconds. The moon is slowly stealing Earth's rotational energy through tidal forces, drifting farther away every year. 4 billion years ago, a day on Earth lasted just 5 hours. The moon loomed enormous in the sky. As time marches forward, days will stretch longer. In the distant future, Earth and Moon will become tidally locked, frozen in a cosmic embrace. But looking even farther ahead, the Sun itself becomes the dominant factor. As it ages and brightens, temperatures will rise beyond recovery. In perhaps 500 million years, the oceans will begin evaporating in earnest. In a billion years, Earth becomes a scorched, lifeless rock. The window of habitability for our world, like all worlds, is finite. At the universe's extremes, phenomena exist that make planetary evolution seem quaint. Black holes, regions where gravity becomes so intense that space-time folds in on itself. At their event horizons, time slows to a crawl. Fall past that boundary, and you're severed from the universe forever. But black holes aren't just cosmic dead ends. They're engines of creation. When matter spirals into their maws, it radiates more energy than entire galaxies. Supermassive black holes shape the evolution of cosmic structures on scales that dwarf human comprehension. Then there are theoretical possibilities, wormholes, hypothetical tunnels through space-time that could connect distant regions of the universe. Einstein's equations permit them, but we've never detected the exotic matter needed to stabilize them. And scattered throughout the cosmos, we observe events we still can't fully explain. Fast radio bursts, carrying as much energy as the sun emits in days. Stellar explosions that outshine galaxies, then fade mysteriously. Dark matter and dark energy, comprising 95% of the universe, yet remaining completely invisible. We're mapping a universe where the known is vastly outweighed by the unknown. We live in a universe of extraordinary abundance. Billions of galaxies, each containing hundreds of billions of stars, many hosting planets. The statistical probability that we're alone has become vanishingly small. And yet, the great silence persists. But perhaps we're looking in the wrong places, or listening for the wrong signals. Or perhaps we're simply early. The universe is 13.8 billion years old, but it will shine for trillions of years to come. Maybe we're among the first to wake up and reach for the stars. The search continues. New telescopes push deeper into space and time. New missions prepare to sample the seas of distant moons. And somewhere out there, in the depths of space, or hidden beneath the ice of a frozen moon, the answer to our oldest question is waiting. We just have to keep looking.